Okay, hey, we're back. And we're saying we were starting with writing the electron configuration of each of these. So sulfur has how many electrons? 16. S2 minus, sulfur 2 minus, we looked at that last class. It needs to gain 2 electrons to be stable, so often it will gain 2 extra electrons. So that's 2 more extra electrons that it doesn't need. So it has, that's what this 2 minus tells us, 2 extra electrons. So it has 18 electrons. So we want to start adding in electrons until we get to sulfur. So remember, this is the S column over here. Everything over here is P. Then we have the D section and the F section. All right, so we're just going to add electrons one by one. So first we have the first energy level, hydrogen and helium. So we'll add our first 2 electrons. They're first energy level, S, because we're over here, and S only holds 2. The sunny room only holds 2, right? But you can see that because there's a space for 2 atoms here. All right, so that's all that's in period 1. So then we go down to period 2. So let's write a 2. And this is S. And S can, if we holds the 3rd and the 4th electron. So we'll write S2. Well, then we just keep on going. We jump across, and now we're into still the second energy level, but now we're into the P sublevel. So 2P. And 2P will hold up to 1, 2, 3, 4, 5, 6 electrons. 2P6. All right, so now we're up to the same amount of electrons as neon, but we need to get to sulfur. So let's drop down to the 3rd energy level. So now we're going to write 3S2. And then we'll go across, and then we have 3P, 1, 2, 3, 4. 3P4. That's the electron configuration for S. What about S2 minus? It's going to be the same thing, but with 2 more electrons here, right? It'll be full. It'll have the same electron configuration as argon. So we'll just rewrite everything, but with the 3p6 at the end. 1s2, 2s2, 2p6, 3s2, 3p6. Okay. So it says explain why the radius of the S2 minus ion is larger than the radius of the S atom. So basically they're saying sulfur is this size and S2 minus is a little bit larger. Why? Well, there's 2 extra electrons. We just added 2 extra electrons. Otherwise, they're identical. Okay, what do electrons do? Do they attract or repel? They repel each other. So S2 minus is going to be larger because of electron repulsion. So larger due to electron repulsion. And that's expanding the atom. The electrons on the outside are spread out further to try to get further away from each other. All right, now let's look at this third question. Which of the 2 species would be attracted into a magnetic field? And explain. Well, we have to look at these 2 sections, S and P, okay? So if we remember, the pink room has 3 sections. Each one will hold 2 electrons, right? There's if you remember looking at that picture, there's like 4 different bubbles, right? The electrons can be held in. There's 2 that can go in the x-axis, 2 in the y-axis, and 2 in the z-axis. So that's where we get these rooms from. X, Y, and Z axis, 2 in each one. So for Regular sulfur, we're going to fill in. Remember, they spread out first, one electron in each box, and then we go back and then add the other electron. So that's what the highest energy level would look like. If we did that for 3p6, however, they would still fill in each box first, and then we'd come back and fill in the others. So they're all full. All of the boxes are full. So if you remember that to talk about magnetism, magnetism comes from unpaired electrons. These electrons are unpaired, so they'll create a little bit of a magnetic attraction to a magnetic field. So you could explain by saying S2 minus has 2 unpaired electrons. Which makes it magnetic. All right, let's jump ahead to the next thing. So this is a PES graph. So we can see the elements, the energy configuration here. So what is the likely identity of this element? Well, this is the 1s2. It says assume all electron subshells are full. So we can assume that this 1s is full. We can assume the 2s is full. And we can also assume that this 2p here, 2p6 is full too. So 1s2, 2s2, 2p6. That's 6, 7, 8, 9, 10 electrons altogether. So that is most likely going to be neon. Right? So remember, the higher energy is here, the lower energy is here. The closer the electrons are, the more attracted they are to the nucleus, right? Like the girls are closer to the boy band, they're more attracted. So what if we're sketching a spectrum for carbon? Well, carbon is, it only has 2 electrons in the 2p area. Otherwise, it would be the same thing. So you would sketch the first triangle, the second little triangle, and then the 2p would be, it's also 2 electrons, so maybe a little bit broader and a little bit higher, but that's what it would look like. All right. Of the following, which will have the greater electronegativity? Fluorine or bromine? Okay, well, fluorine is here, bromine is here. So our trend, you should also be able to explain why, okay? So electronegativity is how electron hungry an atom is, how much it's going to attract other electrons. So the less electron shells it has, the more it's going to attract electrons. And fluorine is in the second period. It has 2 electron shells. Bromine, on the other hand, it's in the 4th electron shell, so it has 1, 2, 3, 4. Okay, this is a lot of more electron shielding. So the nucleus cannot attract electrons as much, okay, as fluorine can. Right? It doesn't have all these VIP girls filling up the seats, like pushing other electrons away. So in this case, it's going to be fluorine. What about cesium or radium? Here's cesium. Oh, cesium or radon. Cesium is here. Radon, it's been a while since I looked for that one. Where are you hiding? Oh, there you are. So left to right across the periodic table, what happens? In this case, you keep adding protons, right? Cesium has 56 protons with a positive charge. Radon has 86 protons with a positive charge, but they're both in period 6, so they have the same 6 energy shells. So this is the biggest factor. So radon is going to be the largest, or the most attraction for electrons. It's got more protons. There's more boys in the boy band. All right, smallest radius to largest. So the trend is that as you go up and to the right, things get smaller. So that's going to be boron, carbon, and nitrogen. For the same reason, right? Carbon has another extra proton, so the atom gets squeezed smaller. Oh, no, wait, it says smallest to largest. So that's not going to be right. What about argon, xenon, and krypton? Well, that's not even in order, so that can't be right. So now we just have to deal with ions. Okay, we said S2 is larger than S. Is S going to be larger than chlorine? Yes, it is, because atoms get smaller. So chlorine is the smallest, S, and then S2, so it's going to be C. We can go past the others. All right. Let's. I'm just going to go over maybe 28, and then 30. So 28 atoms of calcium combine with bromine to form an ionic bond. What ratio would they combine in? So if we look at Ca, it is in group 2, and it tends to form 2+ ions. So it has 2 valence electrons, so it basically loses 2 so they can get to 8. So Ca has a 2+ charge, okay? What about bromine? Bromine is in 7. It needs to gain 1 electron, so it will do that. So we put a little negative up here to show it gained 1 electron. So we need to balance these 2 out. So in order to balance this 2+ over here, we're going to need 2 bromines. So the formula would end up being CaBr2. What other compounds have the same ratio with Ca? Anything in the noble gases. So you could write that. Or not noble gases, any of the halogens. Okay. So CaF2, CaCl2, Cli2. What elements could form an ionic bond with sulfur? Well, sulfur is in 6. It has 6 valence electrons. So if it gains 2, it will have an electron configuration that's stable. So oxygen sulfur also often has a 2- charge. So what has a 2+ charge? What could lose 2 electrons to match it? Beryllium, magnesium, calcium, strontium, any of the alkaline earth metals. All right, let's take a look at 30. What's the correct name for the compound with formula Ca3P2? I gave you this in the notes, so you don't change the first name, the metal. You just write calcium. And then for the last thing, you just change the last part of it to "ide." So instead of phosphorus, you'd have phosphide. Okay. So calcium phosphide. Answer would be E. All right, I hope this has been helpful for you. Good luck tomorrow, and I'll see you tomorrow.